Hello, my name is Juan Avalos, and for my topic for the project will be risk management, specifically cancer, and to be more specific, breast cancer. So, for the introduction, when it comes to risk management, the two things are intertwined with each other, which will be hazard and risk. Hazard is anything that can cause harm, and risk is the chance that somebody will be harmed by that hazard. So, when it comes to my topic, which will be cancer, cancer will be the hazard, and it could cause harm, which is cancer could cause severe harm, and the risk is the chances of you actually developing that cancer, and like the chances of the risk of dying from it, and or the risk of developing a severe cancer. And when it comes to cancer risk, I got this from cancer.org, and 1 in 2 males develop cancer in their lifetime, while 1 in 3 females develop cancer in their lifetime. And then here, the next following bullets are steps when it comes to analyzing risk management. So step one, identify the risk. In this case, it will be cancer. So you identify that you got cancer, or the doctors tell you you've been diagnosed with cancer or a certain type of cancer. Step two will be analyze the risk. So when it comes to this part, you'll most likely be looking into what led to you developing cancer, which can be either the factors of your age, your genetics, being obese, lacking certain vitamins. Step three, which will be evaluate the risk. In this step, it will be what type of cancer you have, uh, or the chances of you getting like your cancer getting worse over time. Step four, and eventually after you've been diagnosed with cancer and this stuff, you inevitably treat the risk, which will be treating the cancer. So you will get all these not experiments, all these procedures, treatments in order to be able to get rid of that cancer. And then step five, monitor and review the risk. When it comes to cancer, it's sad to that this is true, but cancer does not always can get rid of. So there's still a chance like the cancer comes back, you have to go through all that process all over again. And for the problem, well, I found an article about, and the article is association between 25 vitamin D concentration and breast cancer risk in an Australian population. And then this article is pretty much a relationship between the lack of vitamin D that relates to breast cancer. So they're trying to make that connection to see if this is this the lack of vitamin D that can be a cause of breast cancer. They use different doses of the 25 OHD concentration are used in the test. And well, with more information coming out, is from uh, scientists are pretty much debating if 50 and moles per liter are enough of a concentration to actually have a lower risk of cancer. And to this and right now, uh, scientists believe that 50 is not enough, and that the minimum should be 75. Methods. So when solving this type of problem, as we learn in class, there's three equations: the odds ratio, attributive risk, and relative risk. So when it comes to these three, uh, when the relative risk is greater than one, it means that there may be a relationship between the exposure and risk. And same goes for attributed risk. When it's higher than a zero, it means that there may be a relationship between the exposure and the risk, and the odds ratio when it's greater than 1 is to show that there is a relationship. And then in this article, uh, they have two groups pretty much. They have the control group and then the cases, which they call cases. The cases are the women that have been diagnosed with breast cancer, which is 214 newly diagnosed women with breast cancer. And control group are obviously the women that have not been diagnosed with breast cancer, and I believe those were the number one were 150 something. They usually break down the groups by the age, which is less than 50 years and greater than 50 years. This way, they'll be able to break down even the test even more to suggest that maybe the lack of vitamin D in this certain age group leads to a higher risk of breast cancer compared to being older than 50 years. And then what's also important is that they state that the seasons of the when the blood was drawn is very important as well. Uh, when it came to the results, 1,060 women were tested, which shows 214 cases that were actually diagnosed with breast cancer, and 152 matched controls, which means that women that were not diagnosed with cancer. And in this article, that 0.1% that had diagnosed with breast cancer. And then in this article, the authors state in the results confirming our prior hypothesis in this observational case control study, women with breast cancer were significantly more likely to have vitamin D insufficiency or deficiency. The odds ratio of breast cancer were 2.5 times higher in women with the concentration of less than 75, adding further support to that the optional level is at least 75. With this quote that I got from the article, it's pretty much the results show that the previous minimum dosage or concentration that they had, which was 50, wasn't enough, because that still led to an increase of breast cancer compared to what they believe now to be the minimum, which should be 75 moles per liter. So, here's a table of the results. It's a little blurry, but it's pretty much showing the deficiency of of vitamin D, and here's breakdown by the number of the cases and the controls, and then the overall. And so, when it came to the cases, they break it down into severely deficient, which is less than 25 of the concentration, deficient, which is 25 to 49 of the concentration, insufficient, which is 50 to 74.9, and then sufficient, which will be the new goal, which will be 75 of the concentration. And here's another table showing the odds ratio, which is a method that we learned in class of the concentrations, and it shows, and as you can see by the graph, when they have a severe less than 25, they have a higher chance of getting the cancer of breast cancer compared to deficient, insufficient, and sufficient. Because the more you take of vitamin D, it pretty much helps you to prevent getting breast cancer. It doesn't guarantee that you don't get breast cancer, but it still helps. And as you can see, they still break down the columns by the age groups, which will be less than 50 years and over 50 years, and the BMI, which will be the obese level, which will be less than 30, which means that you're not obese, and over 30 means that you are obese, and that can also lead to deficiency in vitamin D, and which will also lead to be another factor to breast cancer. In conclusion, in this article, women with inadequate 25OH, the concentration are at increased risk of breast cancer. And with this, like, it's pretty much obvious that the less amount of vitamin D, like, you're more sus. Anyways, and then with risk management, this whole testing result were achieved without having that breakdown, knowing where the hazard is coming from, and this lack of knowing the risk of breast cancer, we wouldn't be able to go to the depth of breaking down this research. Well, what I'm trying to say with this is that without the thought of risk management, being able to analyze um, the hazard, which will be cancer, in this case breast cancer, being able to break it down to what leads to having breast cancer. In this case, I thought maybe is the lack of vitamin D, or the age of the women that had been diagnosed with cancer and not diagnosed with cancer, and being able to break down that information and being able to make a connection. And it's a whole point of risk management, of being able to, like, decide of not decide, but be able to analyze and be able to get the results that you need to find a relationship between the two factors. And here are my sources. Thank you for listening.